Today, we will familiarize ourselves with trigonometry, which is an important branch of mathematics. Let us now discuss some situations. Raju is flying a kite in a field near his house. Can you tell how high the kite is from the ground? Sangeeta and her friends want to know the height of the mountain before climbing the mountain. Can they do that? Standing on the banks of the river, Meena is watching the crows sitting on the electric wire on the other side of the river. Can you find the distance between the crow and Meena? In many such situations, we find ourselves unable to find the height and distance. But it is not that these heights or distances cannot be found. These can be found with the help of a mathematical technique which is a branch of mathematics called trigonometry. The word trigonometry originated from the three Greek words tri, gon and metron, in which tri means three, gon means side and metron means measure. In fact, in trigonometry, we study the relation between the sides and angles of a triangle. Let us now consider this right angle triangle, in which angle B is right angle and angle A and angle C are acute angles. Which side is hypotenuse in this triangle? We know that in a right angle triangle, the opposite side of the right angle is hypotenuse. In the same way, can you tell the opposite side and the adjacent side of the angle C? Well done! If the opposite side is AB and the adjacent side is BC, then can we say that with respect to angle C, the hypotenuse is AC, the opposite side is AB, and the adjacent side is CB. How many ratios can be found if you calculate different combinations of ratios between the three sides of a triangle? Let's see. Now, if we write the ratio between the given sides, then we get these 6 ratios. Now, if we study the obtained ratios with respect to the angle C, we get these 6 trigonometric ratios, which we call sine of angle C, cosine of angle C, tangent of angle C, cosecant of angle C, secant of angle C, and cotangent of angle C respectively. And in short forms, we show these with sine C, cos C, tan C, cosec C, sec C, and cot C. These are known as trigonometric ratios of angle C. We know that to find all trigonometric ratios, we need to know the 3 sides of a triangle. Can you tell the measurement of the third side of this triangle? Perfect! For this, we can use Pythagoras theorem. From this, we get the length of PQ, 12 centimeters. Now, we can find the trigonometric ratios for phi. Can you tell me what those ratios are? Well done! These are sine, cos, tan, cosec, sec, and cot. In the previous video, we learned that the ratio between the opposite side of the angle and the hypotenuse is the sine of that angle. Can you tell the opposite side, the adjacent side, and the hypotenuse for the angle phi in the triangle PQR? Very good! The side in front of right angle is hypotenuse PQ. The side in front of angle phi is opposite side QR, and the remaining side PQ is the adjacent side. So, by substituting the values of the opposite side and the hypotenuse, we get sine phi equals to 5 upon 13. Similarly, we know that the cos phi is equal to the ratio of adjacent side to the hypotenuse, from which we get 12 upon 13. Tan phi will be equal to the ratio of opposite side to the adjacent side. Also, we learned that cosec, sec and cot are the reciprocal of sine, cos and tan. In this way, we write all the trigonometric ratios for the angle phi in the triangle PQR.
Find the values of the following. Let's discuss the first part of the example. We can see that the first term given is cot 54 upon tan 36. Here 54 and 36 form a pair of complementary angles. Similarly, the second term also has a pair of complementary angles and the third term is -2. To solve this, we will use the trigonometric ratios of complementary angles. Therefore, here, in the first and second terms, we will either change the cot to tan or tan to cot. Because we know that the cot theta equals tan 90 degrees minus theta and tan theta equals cot 90 degrees minus theta. Here, we change cot theta to tan 90 minus theta as per our convenience. So, the first term of the expression cot 54 degrees is written as tan 90 degrees minus 54 degrees, which gives us cot 54 equal to tan 36 degrees. And similarly, in the second term, cot 70 degrees equals to tan 20 degrees. On solving this, we get the value of tan 36 degrees upon tan 36 degrees and tan 20 degrees upon tan 20 degrees respectively in the first and second terms, which on further solving gives the value of the given expression as 0. Similarly, if we talk about the second part of the example, then this expression is in sine and cos, the first two terms of which are complementary angles. And we know that sine theta equals cos 90 degrees minus theta and cos theta equals sine 90 degrees minus theta. So here, in the first term, we change sine to cos and in the second term, change the cos to sine. After solving further, we get the value of the given equation as -2.
We know that an equation is called an identity when it is true for all values of the corresponding variable. But can you tell what is trigonometric identity? Well done! An identity relation related to trigonometric ratios of an angle is called trigonometric identity if it satisfies all values of the angle. If the value of sec theta plus tan theta is p, then can you prove that the square of p minus 1 upon the square of p plus 1 will be equal to the sine theta? Let's see. We discuss the left side of the given equation, where, according to the given information, p is replaced by sec theta plus tan theta, from which we get the following equation, which we write as follows. And in this equation, using the trigonometric identity, 1 plus tan square theta equal to the sec square theta, after solving, we obtain tan theta upon sec theta. But we know that we can write tan theta as sine theta upon cos theta and sec theta as 1 upon cos theta, from which we get the left side value sine theta, which is equal to the right side of the given equation. Thus, we proved it. But is this the only way to prove this equation? No, we can solve it in other ways also. Let's see. Given that sec theta plus tan theta is equal to p, which is represented by equation 1, and we know that 1 plus tan square theta is equal to sec squared theta, which we solve by keeping the square of sec theta minus the square of tan theta as 1. And from equation, we know that sec theta plus tan theta is equal to P, which is substituted here. We get sec theta minus tan theta is equal to 1 by P, which is represented by equation 2. Now, if we add equations 1 and 2, we get sec theta is equal to P square plus 1 upon 2P, which we can also write in this way, since we know that cos theta equals to 1 upon sec theta. Similarly, if we subtract equation 2 from equation 1, we get tan theta is equal to P square minus 1 upon 2P, where we change tan theta into sin theta upon cos theta. After solving, put the value of cos theta. And see that on solving, we get the same value of sin theta that we were given in the question. Thus, we proved that both sides are equal. At last, a question is given to you to solve. So hopefully, you must have understood this example based on trigonometric identities.